Welcome to SP Smart's NEET Direct program. Today we shall discuss previous year questions asked in various competitive exams from the chapter of magnetic effects of current and magnetism, day 1. So let's start from question first. बहुत लंबी वायर है, इसे इस शेप में बेंड किया गया है as written in this problem, and you are supposed to find net magnetic field at the center O of the circular loop. This is what has been asked in this question. As you can see, we can divide this problem into two parts. One is field due to this straight wire, and field due to straight wire, I write B1. It is mu naught I by 2 pi r, right? And the second part of the problem, we consider only this circular loop. Field at the center of the circular loop, I call it B2, is mu naught I by 2r. Now, using right hand grip rule, we find that in both the cases, the field is acting outward from the plane of the paper. So, the two fields are in the same direction. They can be added up. You can write mu naught I by 2 pi r plus mu naught I by 2r. Simplified further, mu naught I by 2 pi r is 1 plus pi. So, this is the answer to this problem. Now, let's check out which option has this. Well, mu naught I by 2 pi r, pi plus 1. Mu naught I by 2 pi r, pi plus 1. So, as you can see, C option is the correct option for this problem. Okay, now let's move on to question second. The magnetic induction at point O in this figure is given by, well, बहुत clear है एक चीज that we can find field here only due to this loop and this loop, not because of these two. Why? Because by using Maxwell's right hand grip rule, we find that field due to this part of the wire exists here, there, but not here. Similar field due to this wire exists everywhere around it, but not here. That simply we conclude that here we are supposed to find field due to this semicircle and due to this semicircle. Using right hand grip rule, we find field due to this R1 is inwards and due to R2 it is outwards. So that we conclude is inward and outward. The two fields therefore will be taken as difference. The resultant field is due to the bigger this loop is mu naught I by 2r2, and this is B2, and due to the smaller loop it is mu naught I by 2r1. But here inward, the loop which is inward is taken as positive, therefore field B1 is positive, whereas B2 is leaving, so it is taken as negative. And since these are semicircles, I have to take half, because the formula I wrote here is the field due to complete circle, but here we have semicircles, so we have to take half values. B therefore is B1 minus B2, that is mu naught I by 4, 1 by R1 minus 1 by R2. That should be the answer to this problem. So let's check out which option has this. Mu naught I by 4. Well, this is the option, because mu naught I by 4, in the bracket you have 1 by R1 minus 1 by R2. So option A is the correct option for this problem. Okay, now let's move on to part third, the question number 3. A proton, a deuteron and alpha particle. Well, charge of proton, charge of deuteron, charge of alpha particle, then mass of proton, mass of deuteron, mass of alpha particle. We have to consider all these values. If charge of proton is E, that of deuteron is also E, but alpha particle is twice of E. Mass of proton, if we take M, for deuteron is 2M, for alpha particle is 4M. So we should know all these comparative values before we start solving this problem. See, what's the question? In the question it is written they are being accelerated by the same potential difference and end up perpendicular to the field, then the ratio of the kinetic energy is, well, idea is quite simple. Due to law of conservation of energy, kinetic energy is equal to potential energy. Ratio of kinetic energy will therefore depend on potential energy. Potential energy in case of same potential difference V is given by Q into V. I can say that kinetic energy is proportional to Q only because V is given to be same, right? ये constant है, same है, ignore it. Now, kinetic energy of proton is to kinetic energy of deuteron is to kinetic energy of alpha particle. Will have charge of proton, charge of deuteron, charge of alpha particle. ये हमने लिखा E to E. E is to E is to 2E. Simplified, you get 1 is to 1 is to 2. That is the answer. And which option is 1 is to 1 is to 2? Option D is 1 is to 1 is to 2. So option D is the correct option for this problem. So in this way, we have finished today's previous year questions from the chapter of magnetic effects of current and magnetism. These questions were taken from various competitive exams. And that's all for today for the NEET Direct program. God bless you all.